It is, isn't it?
Absolutely wondrous.
So that's why I say now, um, do me a favor and let me remind me to hit that record or save button.
Like and subscribe. Oh,
Like and subscribe. Yes, like and subscribe. I think I have like 30 followers now on YouTube.
oh my god. My life.
What's sad is I think this YouTube channel has more followers than my Pokemon YouTube channel.
Oh, bro, I can't wait for the new update to come out
I
on the
still
22nd of this month.
I still haven't bought Sword or Shield.
God, you're depressing. Yeah, I should just leave right now.
You just want any excuse to leave right now.
Yes.
All right. So
I want an
let's.
excuse to lay down.
Did we do slide 15?
Yeah, you're explaining and then you just like, yeah, I am, but head up.
I didn't say I was about to head out. I said that I think Nick's mind's about to explode right now.
No, no,
Well,
no.
I guess I can't really prove it because I don't have the recording.
Exactly, because you gotta hit save.
So, what we're going to do for this one, let's say we're trying to figure out this formula. So, if we're trying to figure this out, we're just adding this together. So, what we can do is we can use the sum formula of cosine because we already have the. Why are we using cosine? This is. I don't know why they're using cosine. That's weird to me. But what they're going to do here, oh, they're making us solve for it. So 25 plus 144. This is 169. So, in other words, this is 13 when we square root it. That's weird, but okay. So, if we want to figure out this angle and we want to figure out what this side is going to be, and we don't know what this angle is, what we can do is we can use our sum and distance formula. So, here, this is 30 degrees, and we're going to go to our little worksheet and we're going to be adding for cosine. So we're going to do cosine of alpha, cosine of beta, and then it's going to be minus because remember cosine's always backwards. So if we're adding angles, we're going to be subtracting angles. So what they're going to do here is they're going to do this idea of multiplying them because we're going to be multiplying. Let me move this closer. We're going to be multiplying the cosine and the other cosine. So we get this. And then we're going to be subtracting it. So even though we don't know this angle, we still can figure out what the adjacent and the hypotenuse are by either looking at it or by simply using the Pythagorean theorem to figure out the missing side. The thing that we're doing here for this cosine of 30 though is this one we're using the unit circle. So we can scroll down here to the unit circle. Cosine is the x value. So we're going to be using this value right here. All right. So from here, what we're going to do is just plug it in and solve for it. I think this one's a weird one that they're making us do it for the sine of x. So let's see how we do this for an actual problem. Use known values. So we're going to try to figure out cosine of 255. Well, if I add these two angles together, that's the same thing. So I can do cosine of my alpha is going to be 120 and my beta is going to be 130. I'm going to focus on alpha and beta more because that's what the worksheet is. And also, I know those letters. Last time Andy had to school me on Greek letters because I don't know my Greek letters apparently. And I probably should. Because when I took multivariable calculus, like that whole class was basically in Greek. All right, so we're going to do cosine of alpha. So we're going to do cosine of 120. And remember, cosine is the one that has the double cosines right next to it. So then we do cosine of 350 or 135. I don't know why I said 350. And because we're adding it, cosine's the weird one where we subtract. And we're going to do sine of 120 and sine of 135. So that's all we're doing is we're just using this formula. I just kind of remember that cosine has A then B for the cosines, and then it's opposite and then sine. You guys can memorize it whichever way you want, or you guys can literally just write this down somewhere to make it easy for this module. And this law does come into play when we do the activity. I think I already have a video on YouTube. I'm just going to put it on this playlist so you guys can see how to start it up. And if I say, okay, Robert, it's because it was a video I recorded for Robert. So let's take a look here. So we want to do cosine of 120. So cosine of 120 is the x value. So we have negative 1/2. So we're going to do negative 1/2. You know what? I just realized we have to do these in steps. So the first thing we're going to do is we're going to want to find the sum. What? Use the identity, set cosine of value. Use the difference between, using the difference isn't going to do that. Find the sum. Use an oh. We're going to use that identity, and that's what I did up here. So what's the next step? So the next step is we're going to figure out what these values are and plug them in. So this says is use the identity to simplify the right side. So the right side is this. I find it weird how it keeps saying use the identity, but we can just do that. So we're just basically looking these up on the unit circle, essentially. So if we're plugging this into the unit circle, we're looking at cosines are going to be the x values, sines are going to be the y values. That's where they get these numbers from. From here, it's like, well, what's the next step we're going to do? Okay, so the next step, now we're going to multiply all of these together. So we're going to multiply these together, and that'll help us. Simplify the answer by multiplying both sides by 2. That's just tricking us. Simplify your answer by multiplying and then subtracting. So they kind of did this all in one step. So that's all we're doing for it. I like how they try to make it sound easy, but if you look at it, it looks really complicated. But it really is this simple. It's just they're just missing steps like, oh, look at the unit circle to plug it in. Everybody okay on this so far? Garrett, you sound all moco-y. You have mocos from the coronavirus?
Jackson, I had the corona, survived it, so you have morning allergies. Loser.
That doesn't really like answer my question if you have mocos from the coronavirus.
No.
Oh, okay. So if I were to look at
I
this,
give you a totally different answer than that entails that I'm saying no.
What?
Yes.
Anyways, so if I'm looking at this, I'm gonna want to try to figure out what I want to do here. So what's the identity I want to do here? So I'm just gonna do, oh, actually, I think they're being nice on this one. I'm just gonna think about this. I'm gonna do this plus 150. So the 135 plus the 150 should be the identity I'm going to use. So it's going to be a sum formula. And of course, they said they don't want. Make sure, oh, Wait, what? Make sure you have used the correct signs and values. Am I missing something? Doesn't 135 plus 150 equals 285? Use the keyboard to enter the things. What does it want us to do? There's Nick.
Hello?
Yeah, I can hear you. I can barely hear you. You sound like far away. Do you have like your AirPods connected to your laptop and then your AirPods are somewhere else?
No?
Okay, you sound better now. All right, Nick, I got bad news and I have worse news. Which one do you want first?
Oh man. Give me the even worse news.
The worser news first? So it's combined with good news. So the good news is I did record the lesson yesterday. The worst news is I recorded the wrong screen.
Oh yeah. I saw the email about that.
Okay, so you already have that news. The other news, the bad news is I don't know what we're doing here, but we're going to figure it out. Oh my gosh, they wanted us to do all of the work. And they wanted us to do the 225. Why would I use that one when I can use the other one? That's dumb. And then they only want the answer too. So this is Admentum being Admentum at its Admentum myth. You guys know what I'm trying to say. It's just Admentum being Admentum. So they wanted this specific one and they only wanted the answer. So I really hate how Admentum does this. So you can look at the work here. So they said one option is to do that. Personally, I would have done cosine of 150 plus 135. And it's not just because I like saying 150. I just think it's easy because they're on the same side of the unit circle. Here's your 150, here's your 135. It makes it really simple when you're doing this because then what you can do is you can just do let's say you're doing 150 first, you do the negative square root of 3 times the negative square root of 2 here. And then because it's law of cosines, and when you're adding your things, you want to subtract it, then you're going to say all of this is minus these versions. So square root of 2 over 2 times 1/2. So this one you would get square root of 5 over 2 minus square root of 2 over, oh, this is over 4, sorry, because 2 times 2 is 4. I know what 2 times 2 is, guys. Don't judge me. And you end up getting this. So if you look at their answer, they just wrote it backwards. But apparently I don't know what 3 times 2 is. I fixed it. Does that make sense? Anybody lost? Garrett, are you awake enough to understand this?
I'm still here, yeah.
That wasn't what I asked. So what I asked is, are you awake enough to understand what I just did?
Yes.
Okay, cool. Nick, you good?
No.
I'm just like kind of looking at it.
That's
it. Yeah, I'm just like looking at it, soaking it in.
So basically, this is cosine of that. So if you look on the unit circle, that's that. And then we're doing this. And if you look on the unit circle, the x value at 60 degrees is 1/2. And then this minus comes from the formula. So remember, cosine's the one that's backwards. It has a plus sign. This is a minus sign. So the way I remember it is cosine is cosine, and it's the opposite of whatever's here. So if it's a plus, it's going to be a minus, then sine, sine. The way I remember sine is if it's sine alpha plus beta, it's going to be sine alpha cosine beta, then the same sign here, sine beta cosine alpha. That kind of makes sense? Did I go too fast?
No, that makes sense.
So it's just the way I remember it is it's a plus, plus, and then first it's sine alpha, then it's sine beta. And then obviously it's going to be the opposite for the cosines. They kind of have it a little weird on the formula, but it's the same thing. So on the formula, they have it as, sum and difference. They have it as cosine alpha. I like thinking of it as sine cosine, sine cosine. It doesn't matter if you switch these two. So I call it sine beta, cosine alpha, whatever helps you remember it. I personally just think of it as sine beta, cosine alpha. That way you can like understand like, okay, it's sine then cosine, then sine then cosine, but for opposite angles. Hopefully that helps. Unfortunately, Admentum's dumb and they only care about the answer. They don't care about the work. So they're like, yep, that's the answer. That's what you put there. All right, let's take a look at another problem. So use the identity for this one. So in this one, I'm going to use the same identity. I'm going to use sine, and this time I'm going to add 150 plus 135. And this means I'm going to do sine of 150. And by the way, guys, if you accidentally write these backwards, it doesn't matter. It doesn't matter what order it is you do it in, so long as you just follow the formula the same way. And then I'm going to do cosine of 135. And then from here, I'm going to do, since it's a plus, I'm going to do a plus. And then I'm going to do sine of 135. And then I'm going to do cosine of 150. 50.
Like you had 150. 150.
You guys not like it when I say 150?
No, it's just you do.
It hurts when I say 150.
Yes.
All I picture is Vince saying
Exactly, dude.
Did Vince say 150 a lot?
Yes, he's the one who told you to say it.
Oh, that's right. All right. Oh, didn't someone record me saying that and then put it on the internet or something?
I think that was Vince. I have no clue.
All right. So we're going to do sine. So if we're doing sine of 150, we're going to go to 150. And because it's sine, it's the y value. So this is 1/2. And we're going to multiply it by cosine of 135. So I'm going to go to my 135, and that's going to be negative square root of 2 over 2. So I'm going to put negative square root of 2 over 2. I'm going to do my plus sign from the formula, and then I'm going to go to 135. So I'm going to go to 135 for the sine, which is square root of 2 over 2. And I'm going to do cosine of 150. So I use the x value. If it really bugs you guys saying 150, I can stop. You guys want me to stop?
No, it's okay. It just reminds me of Vince.
This reminds me of Vince. What about you, Lily and Andy? Are you guys cool with me saying 150? I'm going to take their silence as a it's okay. Or the fact that they didn't write anything as in the chat as an it's okay.
I'm thinking about it, like, I don't know.
It's like, do I want to hear him say 150? This is square root of 3 because negative square root of 3 over 2 is the cosine at 150. And then when we multiply these out, we end up getting this negative square root of 2 over 4. And because this is also over 4 as well, we can just put the whole thing over 4. So I'm just going to erase ds. And then I'm going to do a negative times a negative is a negative. I'm sorry, a negative times a positive is a negative. And that's going to be square root of 6. So my answer, if this thing doesn't like crucify me for not doing it the way it wants it to, I'm going to do negative square root of 2 minus square root of 6. And I'm going to put it all over 4. Yay! We did it, guys. We found the exact value. By the way, I took my when I took my test to see if I could teach calculus, I forgot to take my graphing calculator, and I had to use sum and difference formulas to solve for it instead of just plugging this into a calculator. I had to literally do this because they're like, a scientific calculator is not the same thing as a graphing calculator.
Oh, that's nice.
Yeah, it was nice. It was not nice. I was like, this has less stuff I can do on it. I can program the answers in a graphing calculator. They're like, nope, it says graphing calculator. That's not a graphing calculator. Good luck on your test.
Oh, nice.
So we're going to do the same thing here with the tangent. So tangent's going to be plus 135. I like how we spent all this time proving it for cosine and we never proved it for tangent. So I don't know what Edmentum's thinking is on that. So tangent's a lot harder, unfortunately, because remember, tangent is y over x. So we're going to have to be a little creative when we're doing this. All right, so I'm going to do the sum formula for tangent, which honestly, I'll be real with you, I never memorized this formula. Okay, it's tangent plus tangent over 1 minus tangent times tangent. Probably still not going to remember it after this. That's why I give you guys this so you guys can print it out and it help you during the test. So when we're doing this is going to be tangent at 150 plus tangent at 135 over 1 minus tangent at 150 times tangent at 135. All right. Who's ready to do some unit circle?
I am.
All right, cool. So if we're doing the tangent at 150, tangent at 150 is 1/2 times 2 over negative square root of 3. The reason why this is we're going to do y over x, or that's the same thing as y times 1 over x. So I'm just flipping over my x here. So when I do this, I end up getting, these cancel out, and I end up getting this negative square root of 3 over 3. What I did here was I multiplied the bottom by square root of 3 and I multiplied the top by square root of 3. So I end up getting this negative square root of 3 over 3. And I'm going to add it to whatever tangent is at 135. So I'm going to erase all this. And then I'm going to do tangent at 135. I hate doing tangent, guys. I'm sorry. I can only imagine that you guys hate this just as much as I do. So what happens here is this cancels out, and we're just left with -1. So this is just -1. Now what's good is I figured this out. So I can just use these again later. So now that I did all this, I can do this. I can do this 1 minus, and then I'm multiplying these two together. So that's the beauty of this, is you can literally just multiply them. It looks nice and simple now. So we end up getting this minus. It looks simple, but it's actually pretty hard. Oh, actually, no, we're multiplying it. So luckily it's multiplication. So we just multiply straight across. All right. So now we're going to get this. We're going to end up getting this. This is -1. So we want to convert these ones to 3 over 3. So this becomes negative square root of 3 all over 3. And it's -3. So what I did here was I changed the -1 to -3 over 3. That allowed me to have the same denominator. And then I'm going to multiply this by, my denominator here is going to be 3. So I'm going to put a 3 here. And on the bottom, I'm going to have this 3 minus square root of 3. Did that make sense, or did I skip too many steps, guys?
It makes sense.
Or are you just saying that so I can move on? Or
I hope. Because, yeah, I don't know about tangent.
So does this make sense what I did here? This is all, I changed this to 3 over 3.
Yeah.
Okay. The tangent's the hard part because that's just the y over x part. So if you're having trouble with that, just let me know. Hopefully with practice, you guys will get it. So when I do this, something interesting happens. This cancels out with this. And this one almost cancels out. The only difference is, let's take a look at it. If we look at it, it's -3 minus square root of 3. I'm just writing it in a different order. And this is 3 minus square root of 3 over 3, right? So hopefully you guys took a screenshot, or you guys watch this on YouTube later to get all this work, because I need room. So I'm going to erase all this, at least this last part, because I need the room. Oh, and I erased that little underline thing. I'll keep that here. So in order to get rid of this square root, I have to rationalize it. By rationalizing it, what ends up happening is the middle term cancels out. I end up getting this 9 plus 3. Because if I did it on, like let's say I multiplied it using the box method, what happens here is this is -3 square root 3 and this is +3 square root 3. They just cancel out. And I'm just left with this 9 plus 3. And then on the top, unfortunately, they're not going to cancel out because when we do this times this and this times this, we're both getting this negative 3 square root of 3. So if we multiply it out, we end up getting this negative 9 minus 6 square root 3. Because what happens is we have this square root 3 minus square root 3 square root 3. And then we end up getting this minus 9. Because square root of 3 times square root of 3 is 9. Oh, it's 3. My bad. Are you guys good? Garrett and Nick, you guys are always vocal and you guys are really quiet right now. It's scaring me.
Yeah, we're good.
I want to close my eyes and just sleep forever.
Don't do that.
You don't understand. I'm hanging on by a thread.
No. Garrett's hanging on by a thread and he had COVID. You can't go out like this.
Garrett is like, nah.
You can do this, Garrett. So what I did here was I just reduced this. So I added these two together. That's how I got this 12. And then I combined this and this. That's how I got this negative 12. And then I can separate these. I skipped that step where I separated them. But the main idea is I'm separating them, and that's how I get this. Gary, you can't be out. You got to prove that you're better than Trump.
I said I had. Doesn't mean I still have it.
I know. And
So
that's. Oh no. Does anyone remember what I put for the answer?
I'll be honest.
You're like, I'm gonna be honest, I have no idea what anything was. All right.
I know y over x is amazing.
And Admentum doesn't like the way I wrote it down. Oh my gosh. They didn't want me to rationalize it. So they wanted to stay like this. They're like, yeah, we don't believe in rationalizing, even though everywhere else we believe they're rationalizing. So, yeah. So the only way to do these problems, guys, is apparently to just wait until Admentum gives you the answer, because they change the way they want the answer every single time.
Oh, that's great.
Now on the unit activities though, do it the way I told you guys to do it. That way, like if you get it wrong, I can give you partial credit for you guys showing your work. Even if you guys just literally plug it into the formula like this and you're like, I have no idea what the answer is, but I know this is what it is when I plug it into the formula. And this is what it is. Like I'll give you partial credit for just doing that. Because Admentum's dumb. All right. So let's do this cosine 15. This is one of the problems that I started off saying. Remember I said this can be 45 minus 30 degrees? So yeah. I said that a while back. So I'm just going to do that. I'm going to use the law of cosines. And remember, cosine is the one where it's cosine, cosine. And if it's a minus here, it's going to be a plus here because cosine is weird. Now, luckily, I know these angles pretty well. So at 45 degrees, that means that this and this are equal to each other. And remember, our only options when we're doing a unit circle are this. And the negative versions as well. But these are our options. So if it's even, then I know that my first one, this cosine at 45 degrees, is just square root of 2 over 2. And cosine of 30, let me think of cosine of 30. So if I'm thinking of cosine of 30, I'm thinking, oh, it's a small angle. So if it's a small angle, my y is short. So I have a short y. And if it's going to make this really long. I'm going to have a long x. So if this is long, then I'm going to have this for my x, which is my cosine. So then I'm going to do this. I'm going to square root of 3 over 2. And that's my cosines. I just did my cosines. Now time to move on to my sines, my y values. Well, my y value, it's an even y value. It's at 45 degrees. It's an even angle. So I'm going to say it's square root of 2 over 2. Next, I'm going to do that 30-degree angle. Well, 30 degrees meant I had a short y. So that meant my y was 1/2. Does that kind of make sense, guys? And
Yeah.
if you're still having trouble with it, you can just look at it here. 30 degrees, it's a long x on the unit circle. So that's how come, since it's a long x, it's square root of 3 over 2. It's a short y, so that's why it's 1/2. At 45 degrees, they're even.
Okay.
All right. And again, you guys can literally just look at this. And remember, x is cosine, y is sine. If you guys know that, it'll take you a long way.
All right.
So now we're going to multiply these. So I get square root of 6 over 4. I'm going to multiply these. So since this is also going to be over 4, I'm just going to leave it as one denominator. And then I'm going to add square root of 2. So let's see how picky Edmentum is. I'm pretty sure this is a solid answer. Like, I don't even know what they're going to say about this one. So I said square root of 6 plus square root of 2 all over 4. This better be right, Edmentum. Oh my God. Let me see about this. Wow. Literally, because I didn't put in the same order they wanted, they said it was wrong. So,
That's wrong.
no, it's right, Nick.
It was in the wrong order.
That's not how addition works.
It had to specifically be on the opposite of the right side.
No.
The nearest 10
No.
to the left. You know what I mean?
No. Are you saying that 1 plus 2 is not equal to 2 plus 1?
Someone's a bit mentally
Exactly.
able.
They're the same thing. They're the same thing. They're the same thing. By the way, Nelson made this to kind of talk about how I feel about Edmentum. Where is it? I think that sums everything up.
Yeah. That sums up everything.
All right, so moving on. Now we're going to do it for sine. Okay, cool. So we're doing it for sine. So the law of sines, remember, sine is, I'm going to do the same thing. Sine of 45 minus 30, right? So if I do sine of 45 minus 30, the law of sines, remember, is sine of alpha, sine of the first angle, and then it's going to be cosine of the second angle. And this one's cool. This one likes it to be the same, so I'm going to leave it as a minus. And then I'm going to do sine of the second angle times cosine of the first angle. All right. So again, sine at 45 degrees, the y value at 45 degrees is square root of 2 over 2. The cosine, remember this is the long side. So if this is the long side, my x is very long. So that's square root of 3 over 2. And I'm going to subtract. This is the short. It's short for the y value. It's long for the x, but it's short for the y value. So this is going to be my 1/2. And this one is even. So it's square root of 2 over 2. And again, if you guys need help with this, just look at the unit circle, practice your unit circle. Although, Nick, I know you memorized yours, right? You memorized the unit circle?
Oh yeah, I memorized the entire thing. I even memorized the second one.
Did you even? Oh, Nick even memorized the tangents too, huh, Nick?
Oh yeah. All of it.
I don't. Yeah, that's like on another level because even I didn't memorize the tangents. Nick's like on it.
Oh, graphic memory, you know.
All right, so let's see. This one, there's no way that Edmentum should say I'm wrong on this one. Like, I don't even know how you can argue this. This has to be the answer. Let's see if Edmentum proves me wrong. Any bets?
Yeah, you can get it wrong.
Wow, you're betting I'm getting it wrong?
I think you're gonna get it wrong. There's no way. Let's see.
I got it right.
Oh, you got lucky. You
I
got lucky.
I think because of the fact that it's so obvious that you have to do it this way, I don't know why the other one said I was wrong. That one was weird. But there's your answer, guys. Ah, it's 1-1 in Mentum. Oh no. I don't think I'm gonna be tied anymore after this one. All right. So I'm still gonna do tangent of 45. And remember, tangent's cool on the top. It's like, hey, you're good on the top. But it is not cool on the bottom. On the bottom, it's like, hey, that's the opposite. And it's like, all right, tangent, you're tired, go home. So then we do this. All right. So remember, it's y over x for tangent. That's the hard part. But since Nick already has this memorized, Nick's like, hey, Vic, that's just 1.
Yeah.
Because square root of 2 times 2 over the square root of 2, hey, that's 1, obviously. So that's just what's happening here. Now, at the tangent of 35, well, tangent, again, the y is short at 30 degrees. The x is pretty long. So that's the square root of 3 over 2, but we have to write this backwards. Oh, square root of 3 over 2. So it's upside down because instead of dividing, I'm just saying this. I'm just saying, let me multiply it by it flipped. I'm going to say it's flipped over. All right. So I'm going to flip it over. And this gives me 1 over square root of 3, which is the same thing as saying square root of 3 over 3, because if I multiply this by the square root of 3 over the square root of 3, I get square root of 3. Square root of 3 times the square root of 3 is 3. Oh my gosh. How many times did I say the square root of 3?
As many times as you said 150.
All right. So I get that. That's just my top, by the way. Still have to do my bottom. So here I get 1, and it's going to be a plus. And luckily, remember I said these two are being multiplied. So all I have to do is multiply this times this. So that's just going to be square root of 3 over 3. So I just multiplied my tangent of 45 times my tangent of 30. All right. Now I have to change these ones. So if I change these ones, I get 3 minus square root of 3 over 3, because I'm just changing these ones to 3 over 3. I'm going to change this bottom one to 3 plus square root of 3 over 3. All right. Now, let's see how much Admentum hates me.
Blunt.
It's true, though.
You're not wrong. You're not wrong.
All right. So I'm going to do this. And I'm going to cross this out. And last time Admentum said, hey, don't worry about rationalizing. Let's see if they're still this nice. So in theory, based off the last way Admentum wanted me to do it, this should be my answer. All right. All right. What do you guys think? Is it going to be 2 Victor, 1 Admentum, or is it going to be 1 Admentum, 2 Victor? I think I said that same thing. You guys know what I mean.
No.
Yeah.
So do you guys think I'm going to get this right or I'm going to get it wrong?
Wrong.
Wow. Thanks for the vote of confidence, guys.
Welcome.
Everyone who's not in this class that's watching this on YouTube's like, well, who is he talking to and what are they saying?
Bullying him. So
I think sometimes we can hear you, Garrett, because sometimes you talk really loud and we do hear your voice on the chat, on the video.
that's if I'm pulling like really, really close to my face. Yes.
Oh my gosh. All right. I'm going to try another one. So Admentum, you got this again. I have a feeling that this time they do want me to rationalize it because they are not happy people. All right, if I rationalize this, I end up getting this 9 minus 6 square root 3 plus 9. So I end up getting, and on the bottom, I end up getting this 9. No, 12. I end up getting 12 because it's going to be 9. Oh, 9 minus 3. Never mind, it's 6. Oh my gosh. I'm tired too now, guys. So on the top, I end up getting. Oh, this is supposed to be a 3 also. Oh my gosh, I am tired. Because negative square root 3 times negative square root 3 is 3. So I'm going to say I'm going to get 2 minus square root 3. So first, Edmonton's like, hey, you're cool. You don't have to simplify this. Now it's like, wait, but if you can simplify it and it looks nice, then do that. So let's see if I get it right this next time.
No.
Wow. No confidence?
Oh, you failed this once.
Wow.
Fail this again.
Did I say 2? I want to say I said 2. Oh, no, it's 1. I don't even know anymore, guys. Forgot if it was 2 or 1. Oh my gosh. Remember how I said the answer was 1 minus square root of 3 over 1 plus the square root of 3? They're like, I don't like where you put the negative.
Wow.
They're like, haha, wizard.
They just, yeah, they hate me. Oh, you know what? To be fair though, I think I did. No, yeah. Oh, I had it right. They just, like I said, show your work. If you show your work, guys, like I'm gonna give you credit because at Mentum, their sample answers are always like bad. I swear. So they're just talking about cofunctions. Cofunctions is this idea that if I'm doing the sine of 30 it's going to be the same thing as the cosine of 60. I should have done that in yellow so you guys can see. Sine of 30 is the same thing as cosine of 60. All right.
Yeah.
So unfortunately it's 12, so it looks like is anyone down for a Friday lesson, or do you guys just want me to record the video on Friday and you guys can just watch it on your own?
Yeah. Watch it on our own.
All right, I'll post a video sometime this weekend for you guys to watch it on your own. Hopefully it'll help, because I don't want you guys getting behind. We didn't even get to the lesson activity. That's how long and stupid Admentum is for this unit.
That's nice.
All right, I'll make sure it does record though. All right, guys. You guys have a good one. Don't forget to get your what was it, Unit 3 done.
Oh, okay.
Well, Nick, you've been doing all your work while we do it in class, right?
Sometimes, yeah.